Hi guys, Northern Oklahoma College, College Algebra, Math 1513. We're on Chapter 2, Lesson 6. We're going to evaluate composite functions. Alright, composite functions means basically that you're combining two functions into one. So you have two jobs to do. We have to run something through one function, maybe the f function, and then take that answer and run it through like the g function, a second function. So we're running a number through two functions and we're seeing what pops out at the end. It's called composite functions. Okay, so we have these functions here. F of x equals x plus 1. And my g function, I'll call g of x, and I'll say that's 2 times x. So in the first function, I just want you to add 1 to the number. And in the second function, g, I want you to double the number. All right, let's start with, say, the number 4. And I want to run it through the f function. Well, that means I want to find out what the f function is when I run 4 through it. So instead of f of x, I'm using f of 4. I'm replacing the x with 4. That means 4 plus 1, and 4 plus 1 is 5. So 4, when I run it through the f function, produces 5. Okay, let's take that 5 now and run it through the g function. Well, g of x equals 2 of x equals 2x. G of 5 must be 2 times 5, because I'm taking out the x and putting in 5. 2 times 5 is 10. So when I run 5 through the g function, I get 10. So I started with 4, I ran it through the f function and got 5. Then I took that answer 5 and ran it through the g function and got 10. Now how do we say this mathematically? We say, well, what's the first thing we did? We took 4 and ran it through the f function. Then we took that answer and ran it through the g function, and we got 10. So we say g of f of 4 equals 10. In other words, it's a composite function. When I ran 4 through the f function, all right, think about it this way. When I ran 4 through the f function and then took my answer and ran it through the g function, I got 10. Now another way of writing this, the book likes writing it this way. G, looks like a little open dot there. G of f, parentheses, of 4 gives you 10. So 4, when you run it through the f function and then the g function, produces 10. All right, you guys try this one. Try pausing the video and run 2 through both functions. Do the composite function 2. All right, I ran it through the f function and I got 3. And I'm going to take that and run it through the g function, and I got 6. So when I take 2 and run it through the f function, then take my answer and run it through the g function, I end up with 6 after the composite functions. How do I write this? Well, I started with 2, I ran it through the f function, and then I took my answer and ran it through the g function, and I got 6. Another way of writing it, g of f of 2 is 6. All right, finally, just to make it a little messy, what if we just ran x through? What if we just wanted to know what the composite functions were if we combined the functions together? So let's not put a number in. Let's just run an x through. Okay, so let's run the x through the f function. So I'm doing f of x, and I get x plus 1, because f of x is x plus 1. So my answer is x plus 1. So I put x into the f function, it produced x plus 1. Now, let's take our answer and run it through the g function. Well, g of, what are we putting in? We're putting in x plus 1 equals, that just means I'm going to replace the x in the g function. Let's go up here to the top. That x right there, I'm going to replace it with my x plus 1. Just like earlier, I replaced it with a 5, and then I replaced it with a 3. Now I'm going to replace the x with an x plus 1. So now my function is 2, and then take out the x and put in x plus 1. Now if we simplify that, if we multiply the 2 times the x and the 2 times the 1, my answer is 2x plus 2. So my composite function, when I combine the two functions together, I have 2x plus 2. How do we say that? We say we started with x, we ran it through the f function, and then we ran it through the g function, and what did we get? I ran out of room here. 2x plus 2. All right, what if we do it the other way around now? What if we run it through the g function first, and then we'll run it through the f function. Okay, well, I'm running it through the g function. I'm starting with 4. Remember, we started with 4 last time. So I have g of 4 would be 2 times 4, which is 8. So I run 4 through the g function and get 8. Now I take that 8 and run it through the f function. Well, my f function says f of 8 would be 8 plus 1, because I take out the x and put in my 8, which produces 9. All right, and how do we write it? Remember what we started with. We started with 4. What did we run it through first? We ran it through the g function first, and then we ran it through the f function, and we got 9. So f of g of 4 is 9. That means if you take the 4 and run it through the g function, and then run your answer through the f function, if you do those composite functions, you get 9. Another way of writing it, of course, is f of g of 4 is 9. All right, let's try, you guys try the number 2. So pause the video and run 2 through the g function and then the f function. See if you get the same answer I do. All right, here's what I got. I ran 2 through the g function. That meant I had to multiply it by 2, and I got 4. Then I take the 4 and run it through the f function. That means I have to add 1 to the 4 and get 5. And then write your answer. What did we start with? We started with 2. We ran it through the g function. And then we ran it through the f function, and we got 5. Or f of g of the number 2 produces 5. Okay, what about x? What if we just want to make the composite functions and not put a number in? Let's just put an x in and see what the composite functions would be. So you guys try that. Put x in, pause the video, see what you get. Okay, here's what I got. I took x and ran it through the g function and got 2x. Then I took the 2x and placed it into my f function. I put it in for my x right there. 2x plus 1 is simply 2x plus 1. And then got my answer over there on the right. Now, something interesting here is we can run those numbers. Remember how we ran the number 4 and 2 through? We put the numbers in first and then ran them through both functions. Well, another way to work this same problem is to do your x first. Run your x through, get a composite function, so get this function right here, and then run your 4 and your 2 through. So for example, if I take this composite function down here, if I run my x through and just find out what the composite function is first, and then take my 4 and plug it in for x, I get 2 times 4 plus 1 is 9, and there's my answer, 9. If I take the 2 that I began with over here and run it through my composite function, I get 2 times 2 plus 1 is 5, and I get this same answer here. So there's 2 ways of working this problem. You can either put the number in first and run it through both functions, or you can work out your composite functions, put your x in first, work it out, figure out what the composite function is, and then put your number in. Either way, it's fine. You'll get the same answer. Okay, let's work some examples. Here's a problem you may see in your homework. Given these 2 functions, the f function and the g function, find g of f of x and find f of g of x. It's not the same thing. It depends on which way you run the functions through. So we're going to get 2 different answers here. Now notice, they're not telling us what number to put in, so we're just going to have to run x through the function. Now I'm going to start with this first one here, g of f of x, and I prefer to write it like this. Now just stay with me here and maybe you'll see why. Okay, I am going to run x through the f function. So what is f of x? Well, f of x is x squared minus 11x. So I'm going to replace f of x with x squared minus 11x. And I'm going to leave my parentheses around it, and I'm going to leave my g in front of it because I haven't done the g function yet. All I did was take out the f of x and put in x squared minus 11x because f of x is x squared minus 11x. Okay, that's step 1. Step 2 is take the x squared minus 11x. I'm going to take this and run it through the g function. That means everywhere that you see an x in the g function, you're going to take that x out and put x squared minus 11x in. So g, whoops, let's leave it black here. G of x squared minus 11x would be, I'm going to take my 2 and I'm going to open up my parentheses where the x goes. There's my plus 3 on the end. I'm going to take out that x and I'm going to put in x squared minus 11x. Okay, that's the substitution. We have our answer here. We just need to clean it up a little bit and make it look nice. So equals 2x squared, because I'm multiplying the 2 by everything in the parentheses, minus 22x plus 3. And that's as far as we can go until we find out what x is. Now in front here, I'm going to bring back the g of f of x. So g of f of x, that composite function, when I put the two functions together that way, gives me 2x squared minus 22x plus 3. Okay, now let's do the other one. Let's do f of g of x in the same manner. All right, f of g of x. How do I start? I'm going to start with my g of x. What is g of x? G of x is 2x plus 3. So I'm just going to replace my g of x with 2x plus 3. My f is still up front because I haven't run anything through the f function. So technically what I did right here was I took x and I ran it through the g function and just got 2x plus 3. So nothing really changed on that. Here's where things start to change now, because I'm going to take my 2x plus 3 and plug it into the f function. So in my f function, everywhere I see an x, I'm going to plug in a 2x plus 3. Now remember, it's always a good idea to use parentheses, all right, especially when there's exponents and multiplying and stuff going on. So here's my parentheses, and I'm squaring that, minus my 11, and then here's my parentheses again, where I'm going to put my x. Okay, that's the parentheses are where the x was. So I'm taking the x out and I'm replacing it with 2x plus 3. Okay, it looks messy, but it's not that bad. So up here, f of x, that's my f function. I took out my x's and I replaced them with 2x plus 3. That's the substitution. All we got to do now is clean up our mess. So let's just do a little algebra and clean things up. 2x plus 3 squared, that's 2x plus 3 times another 2x plus 3. And then I still have here, I'm going to go ahead and distribute my negative 11. So I have minus 22x minus 33. See if you guys can finish cleaning it up. You can go ahead and pause the video and finish it up. And this is what I got. I said x, when you run it through the g function and then run it through the f function, is 4x squared minus 10x minus 24. So f of g of x. All right, here's one for you guys. Find f of g of negative 3. This time they're telling us what the x is, all right? So I prefer to write it this way, f of g of negative 3. All right, that's the way I like to do it. You can write it any way you want to. So that means that I'm going to take my negative 3, I'm going to run it through the g function, I'm going to get an answer, and I'm going to run that answer through the f function and get a final answer. All right, so the first thing I'm going to do, this is the way I do it. I'm just going to extend those braces there. The first thing I'm going to do is find my g of negative 3. That means I'm going to run negative 3 through the g function. So I'm going to take out my x's and put in negative 3. All right, now if you don't use parentheses, this is what it looks like, and you're going to get the wrong answer. Remember to always use parentheses where your x was, okay, to make sure you do the math right. And we get f of 9 plus 15, which is f of 24. So that's part 1. Step 1 is run negative 3 through the g function. Now we take that 24 and run it through the f function. And we get our final answer here. Okay, you guys' turn. Find f of negative 8. Pause the video and see if you can work it out. And hopefully you guys got that.